I want you to do something right now. Go stand in front of a mirror. Don't overthink it. Raise your right hand. The person in the mirror raises what looks like their left hand. Now here's the question that sounds like a joke until it eats your whole afternoon. Why does a mirror seem to flip left and right, but not up and down? Your head stays on top, your feet stay on the bottom. So why doesn't the mirror flip you upside down? And here's the scarier version. How does the mirror know left from right? How does it decide what to flip? It's glass. It has no brain, no opinion, no settings. So what is actually happening? Because something is happening, but it's not what you think. Let's pull it apart like a machine. The obvious answer and the hidden trap. Most people say mirrors reverse left and right, and it feels true for a reason. You wave your right hand. The reflection waves the other hand. You look at text in the mirror. It looks backwards. So your brain goes, case closed. But physics doesn't accept feels true. Physics asks, what transformation happened to the light? Because if we don't separate what happens from how it feels, we'll be wrong, confidently. So let's do the most boring thing in science. Slow down, define directions, track them carefully. The key claim, here's the big twist. A flat mirror does not reverse left and right. It reverses front and back. That's it. The mirror flips the direction that points straight into it, the depth direction. Toward the mirror becomes away from the mirror. Away becomes toward. Left and right are parallel to the mirror. Up and down are parallel to the mirror. A flat mirror leaves those alone. So if the mirror isn't flipping left-right, why are we all so sure it is? Because your brain is doing an extra step, quietly, automatically, and it's tricking you. Orient yourself in space. No math, just reality. Let's anchor it. Imagine you're facing a mirror on a wall. Pick the simplest language. Up is up, down is down, left is left, right is right. And there's also toward the mirror and away from the mirror. That last one matters. Point your finger straight at the mirror. That direction is toward. In the reflection, that finger points straight back at you. That direction is away. So the mirror flips that one axis. Now check something else. Put a sticker on the right side of your shirt, not on your hand, on your shirt. Look at the mirror. Where's the sticker in the mirror? It's still on the same side of the room. It didn't teleport across the universe. So what's the reversal you feel? It's not the room changing. It's not east becoming west. It's not left becoming right in space. It's you mislabeling what you see because you treat the image like a person. The real cause, mental rotation. Here's what your brain does. When you look in a mirror, you don't see a weird light field. You see a person. A person who looks like you. Same hair, same face, same clothes. So your brain tries to make sense of it like this. If I were standing over there facing myself, how would I get there? Answer, you'd walk around and you'd turn around. A 180-degree rotation, and when a person rotates 180 degrees, their left and right swap relative to you. So your brain applies that rotation in imagination. But the mirror did not rotate anything. The mirror performed a different operation, a reflection. A reflection flips depth. A rotation swaps left and right relative to the observer. You're mixing the two. That's the whole puzzle. The mirror is doing one thing. Your brain is pretending it did another. Let's prove it with something physical. Grab a piece of paper. Write the word hello. Now do this carefully. Step 1. Hold the paper so the writing faces you, so you can read it directly. Now look at the mirror. What is the mirror showing you? It's showing you the paper as if you were looking at it from the other side. Now step 2. Rotate the paper so the writing faces the mirror. You just turn the paper around. Now the mirror shows the word reversed. Here's the punchline. The mirror didn't suddenly decide to flip left-right. You rotated the paper. You changed which side is facing the mirror. The mirror did the same boring operation both times. It flips depth. Your rotation is what made the letters appear reversed. So when people say, the mirror flips words, what they really mean is, we tend to present words to mirrors after rotating them. Why text on your shirt looks backwards. Now apply that to shirts. Text on your shirt is printed to be read by someone in front of you, meaning they see the front of the fabric from the outside. When you look in a mirror, you are seeing the front of yourself through a depth flip. It's like getting a view that mimics seeing the fabric from the opposite orientation, so the letters look reversed. Again, the mirror flips depth. Your brain calls it left-right because you're mapping it onto a facing person. The killer proof: mirror on the floor. Here's the test that ends arguments. Put a mirror flat on the floor. Stand over it and look down. Now what seems reversed? Not left-right. It feels like up-down got flipped. Your head appears down there. The ceiling seems below. Did the mirror suddenly change personality? No. Same exact rule. A mirror flips the direction perpendicular to its surface. Wall mirror, perpendicular direction is front-back. Floor mirror, perpendicular direction is up-down. So the mirror never had a special obsession with left-right. It flips the axis sticking straight out of it. That's the physical rule. Simple, mechanical, no psychology required. Okay, so why does my ring look like it moved hands? Good question. Let's say your ring is on your left hand. In the mirror, the ring is still on the same side in space. It didn't jump through the mirror to the other hand. So why does it look like the other hand? Because you're doing this in your head. You look at the reflection like it's a person facing you. And when a person faces you, the hand on that side gets labeled differently. So it's not that the ring moved. It's that your label moved. The mirror produced a depth-reflected image. Your brain then tried to interpret it as someone who rotated to face me. That interpretation forces the left-right naming mismatch. You can feel this if you change the situation. Stand with your back to a mirror. Look at the reflection over your shoulder. Suddenly, the left-right mystery feels weaker. Why? Because you're no longer in the face-to-face interpretation mode. Your brain isn't insisting on imagining that rotation. Two mirrors, the unflip effect. Now let's have fun. Two mirrors can undo the weirdness. Why? Because one mirror flips depth. A second mirror flips depth again. Flip depth twice and you're back. That's why setups with two reflections can feel oddly correct, like the image stops doing the annoying switch. It's not magic. It's composition of transformations. One reflection changes handedness. Two reflections restore it. The deeper idea, real but not overhyped, chirality. Now the last layer, still grounded. Your hands are not just different sides. They're mirror image shapes that you cannot match by rotation. You can spin your right hand any way you want. It never becomes a left hand. That property is called chirality. So when a mirror shows your right hand as a left hand, it's not because it swapped the rooms left and right. It's because a mirror reflection changes the handedness of chiral objects. That's why chemistry cares too. Many molecules come in left-handed and right-handed forms, and biology can treat them differently because enzymes are shape selective. So this mirror puzzle is not a toy. It connects to real structure in nature. Reflection is not rotation. Okay, here's the whole answer in one breath. A flat mirror does one thing. It flips the axis perpendicular to its surface, depth. Wall mirror flips front, back. Floor mirror flips up, down. It doesn't choose left, right. The reason it feels like left, right is reversed is because your brain interprets the reflection as a person who must have turned around to face you. That imaginary rotation swaps left and right in your mind, not in the physics. So the mirror is simple. Your brain is the tricky part. Now go try this. Put a mirror at a 45-degree angle. Watch your intuition break. Then rebuild it. That's learning. All right, before you go, thank you for spending these minutes with me. If this mirror thing finally clicked in your head, do me a favor. Hit like, because it tells the algorithm this is worth showing. And if you want more videos like this, subscribe. Now I want to hear from you, for real. What kind of topics do you actually enjoy most? Pick one and comment it. Mind-bending everyday physics, mirrors, time, sound, gravity, psychology tricks, why your brain lies to you. Space stuff, black holes, the Big Bang, why anything exists. AI plus tech explained simply or pure Feynman-style logic puzzles. And give me one specific idea, like explain why airplanes don't go faster. Why do we dream? Why does time feel faster when you're older? Why do magnets feel spooky? Why do shadows look solid? Also, tell me how you want the videos made. Do you prefer short and brutal, 1 to 3 minutes, or long and deep, 10-20 minutes, or both? Because I can do both. And if you want me to break down a specific clip or a topic you've seen on YouTube, drop the link and I'll analyze it properly. Thanks again for watching. You already know the punchline now. The mirror didn't flip left and right. Your brain did. See you in the next one.